Hello, my name is Juan, and today I will be taking you through an experiment where we have to reach to Mars and we have to calculate the window. So let's start with a diagram for a visual representation. So we have the sun right here, and then we have the orbit of Earth right here. And since Mars's orbit's bigger, we have to make it way bigger. Okay, so let's put Mars right here for an example. So first of all, we have to get the range of the sun to the earth. Let's put that as R1. And we also have to put the range from the sun to Mars. So let's put that as R2. So we need to determine the velocity of both of these. So let's put this as the velocity of Earth as V1. And then we put the velocity of Mars as V2. Okay, so let me bring up a concept called Boltzmann's transfer. This is what we use to get to a place with efficient power, so we don't have to waste as much gas, and it's the best way to travel. So right here is called the Boltzmann transfer, right here. Okay, so first of all, for equation, we need to get the velocity of delta V1 as well as delta V2. So to put this in total, we need to measure from Mars to Earth as 2a. Okay, so let's move forward. First of all, if you want to figure this out, we need to use Kepler's third law, which basically is P2 to A3, which equals A3. So first of all, where we got A, we do A equals R1 plus R2. So where we got R1 and R2, and divide that by 2. Now, since we have this, we have to get the astronomical units for both of these. We already know from the sun to the earth is 1 astronomical unit. And to get Mars, we have to calculate that as well, which would come out to 1 for Earth plus 1.52366 for Mars to the sun, divided by 2. Okay, so now you put that into the calculator, which should equal 1.26183 AU, which is astronomical units, which equals to P, which is 1.417 years. So let's do this. Time equals P to 2, which equals 0.17 years, which if we calculate this correctly would be 8.5 months for a space probe to get from Earth to Mars from Boltzmann's transfer, which is a pretty effective way to launch in there. So now let's move forward to when it's launched. So when do we have to launch it for it to succeed? So when to launch. So let's make a little visual diagram here. This will be our sun. This will be Earth right here. And this will be where Mars's orbit will be. So let's cut this in half. This will be 180 degrees right here. So as we spoken right now was that Boltzmann transfer should land us right here. But what angle does Mars have to be in order for this to succeed? So I have an equation here. So we have to put the time divided by the period of Mars, which should equal 180 over theta, which many to you may not be a concept that you heard about, but since I'm doing this experiment, I have learned about it, which means that theta could be anywhere between 0 to 90 degrees. So you have to do that, divide by 360, because the orbits are 360. So we put this into parentheses, and we get the later calculations that we had of how much approximately the years it will take. So it'll be 0.71 years divided by its full orbit, which would be 1.88 years. This one will be at 180 degrees, the orbit of Mars, and here it will be a full 360 degrees, which for Mars would be 1.88 years, which would be way longer than Earth, due to the fact that its orbit is way bigger than Earth. So what we do is that equals to 180 theta, which could be between 0 to 90 degrees, 360. What we get is that it equals theta will equal 44 degrees. So in order for us to successfully launch a probe into space, we'd have to use Boltzmann transfer, and Mars has to be 44 degrees ahead of Earth for it to successfully launch. So for example, you could do this whenever. You have to get the longitudes and the angles of when you want to launch. For example, let's say you want to launch, but it's December of 2018, and the angle that Mars will be at is at 42 degrees. So what you do is you put the time, the period of Mars. So let's do this again. 180 degrees minus 42 divided by 360, which should come out to 37 degrees. So in December of 2018, Mars has to be ahead of 37 degrees in order for us to launch a successful probe to Mars. So there you have it, guys. That's how you calculate windows for Mars to get to Mars. Thank you and have a nice day.